Today we are going to do a lesson on probability, specifically mutually exclusive events. But first we're going to recap probability notation, Venn diagrams, and calculated simple probabilities. Then we're going to move on to understanding what is meant by mutually exclusive and how it affects probabilities. A pen and paper will be useful today, and if at any point you don't understand, pause and think about it. Perhaps go back and listen to something again, because it might then help you understand what's going to come next if you understand everything up to that point. Also, something at the bottom to think about: if you're playing the national lottery, then should you choose the numbers 1, 2, 3, 4, 5 and 6? We'll revisit that at the end. Okay, so first things first, this is a Venn diagram. It's not a mathematical one, but it will demonstrate how one works. So we've got a circle on the left for colour and a circle on the right for fruit, and we have got an overlap in the middle, and we have got outside the circles but inside the box we have got the words red, apple, potato and orange to put in the Venn diagram in the right place. If you want to have a go at doing that now, you need a few seconds to think about it, then pause the video, otherwise I will go over the answer in a few seconds time. So red goes into the colour section, apple is a fruit, orange is both a colour and a fruit, so it goes in the middle in the overlap, and potato is neither, so it goes on the outside. Every single thing has got a place in a Venn diagram, and all of the things we've got here go into the different places. But blue, green, other colours you could go in here, lemon, peach, other colour and fruits you could put in the middle, and banana, grapes and that sort of thing could go here, and chair, table, lots of other things go outside here. Every single thing has got a place. If we have a look at a more numerical one, we've got the circle on the left represents the factors of 24. The circle on the right represents factors of 20. We've got an overlap in the middle for the numbers which are factors of 24 and 20, and we've got a box on the outside for things which are neither. And we want to put the numbers 1 to 12 in their place. Now, I've got the numbers 1 to 12 written in the bottom, and we have got some curly brackets around them. This is notation that we use in probability to list all the possible outcomes of something. So curly brackets, a list separated by commas of all the possible things, and that is called the list of outcomes. So if you want to have a go at this, pause the video now, otherwise we will go on to the answer. So here's all the numbers put in their right places. 1 and 2, they're factors of 24 and 20. So they go in the middle. 3 is just a factor of 24. 4 again is a factor of 24 and 20. 5 is just a factor of 20, etc., etc. And you get the numbers 7, 9 and 11, which are factors of neither of them, and they go on the outside. So you've got all your different areas where you can put your numbers. See how there can be more than one thing in each area and different amounts of numbers in each area. We're going to have a look at this example to help us calculate some probabilities next. So P brackets is notation for the probability of. So we're looking for the probability of getting a number at random and it being a factor of 24. So if we've got these 12 numbers to choose from at random, what are the chances that the one we pick will be a factor of 24? So if we have a look, we have got 1, 2, 4, 8, 3, 12 and 6. They're all the factors of 24 we've got. So there's 7 of them out of the 5 more here, which means 12 total. 7 out of 12, which means that the probability is 7/12. Now also have a look, I said 5 there because 5 numbers are not factors of 24. 5 and 7 makes 12. This probability in the Venn diagram adds up to 1. The probability of every single Venn diagram adds up to 1. That is the nature of probability. So if we have a look next at the factors of 20, we've got 1, 2, 3, 4, 5 numbers, which are factors of 20, out of our 12 numbers, so the probability of choosing one of those is 5/12. It's better to put things as a fraction rather than a decimal because it's easier. Counting 5 out of the 12 was much easier, and it's got meaning. 5 out of 12 is more meaningful than the decimal equivalent. Factor of 24 and 20, so both of them. So that's the bit in the center. You've got these three options, and so 3 options out of 12. That's 3 out of 12, which simplifies to 1/4. Now you can simplify your fractions, but a lot of the time probability will be fine with you leaving as unsimplified fractions because it has that meaning, 3 numbers out of 12. It helps us understand things better. Okay, so if we have a look at factors of 24 only, that's these 4 here. So it's these 4, but it's not the ones in the middle, because only means not factors of 20, so we don't want to include the ones in this circle. So it's these 4 numbers out of 12. 4/12 means 1/3. Having a look at factors of 20 only, we have got these 2 numbers here. We don't want to include the ones in the center because they are in this circle over here. And so it's just those 2 out of 12, which simplifies to 1/6. And one more we'll look at is the probability of neither. So that's the ones on the outsides. There's 3 of them. 3 out of 12. That simplifies to 1/4. Okay, so that's calculating probabilities. Now we're going to move on to looking at mutually exclusive events. So this is important and mostly new information. So you might want to pause it here and copy this down, and then I will explain what it all means. So mutually exclusive events are events that cannot occur at the same time. For instance, if I flip a coin, I could get a head, I could get a tail, I could not get a head and a tail at the same time. The events getting a head and getting a tail are mutually exclusive. If Man United are playing a football game, the event that they win and the event that they draw, they're both possible, but they cannot both win and draw the same game. That is not possible. Those events are mutually exclusive. So if we look at some associated probabilities with that, the chances of A and B happening, so both of my events happening, is 0 if they're mutually exclusive. Getting a head and getting a tail on the same flip is 0. Man United winning and drawing at the same time is 0. And if I want to figure out if one or the other happens, I just have to add the probabilities. So flipping a coin, getting a head, that's half. Getting a tail, that's half. That's all the possible things that could happen there, so add them up, I get 1. All probabilities add up to 1. And Man United drawing and winning, now if I knew the probabilities, I could add them up, but I don't because it's just theoretical. And also those ones would not add up to 1 in that case because there's the third possibility that they lose. So mutually exclusive means they can't happen at the same time, but it doesn't mean that it is absolutely everything. If we look at a Venn diagram of mutually exclusive events, you can see that there is no overlap because the overlap is where they both happen, and they can't both happen at the same time because they're mutually exclusive. So you've got 2 separate circles with space on the outside for a third possible thing that happens. So Man United winning, Man United losing, drawing and then losing on the outside. You might see a Venn diagram with an overlap, but they're mutually exclusive events. That would mean that there is nothing at all put in the overlap, or perhaps a 0 to show that there's 0 chance. Okay, now if you understand all that, then great, you are ready to do today's exercise, which is exercise 8.2, page 176 to 178. You'll also find a link to it on the assignments tab if you just complete it and upload it in the usual way. That's today's work. If you need to go back over this, go back over this. If there's something you still don't understand, then you can ask in chat. Okay, so for A lot of people, that's the end of the lesson, but if you want to talk about the problem I gave you at the start, we can talk about that now. So if you're playing the National Lottery, then should you choose the numbers 1, 2, 3, 4, 5 and 6? Well, it seems silly. It seems silly that the numbers would come up like that. But you might think that, well, they've got just as much chance as any other numbers, so why not? Why wouldn't I play them? But you shouldn't play them. And the reason you shouldn't play them is lots of people do. Lots of people play these numbers, which means if you win, you're going to be sharing the prize with a lot of people. So it's a little bit of a trick. Well done if you said, why not? You should choose them because the probability is the same. Well done, you understand the probability, but the real life factor of humans changes some things there. Okay, so that's all for today. Bye bye.